Hi, I'm Janet Agnoletti. I'm the Executive Director of the Barrington Area Council of Governments. I'm going to refer to our organization's name as BACOG as we go through the presentation. I'm here to talk to you about groundwater. The first thing I'd like to do, though, is thank the Barrington Area Library for hosting this presentation. Thank you very much. So I'm going to talk about groundwater, where our water comes from, why BACOG is studying groundwater, and the components of the BACOG Water Resources Initiative. So first I'd like to tell you a little bit about what BACOG is. We're a planning and advocacy organization, and we are advisory to our members. Our members are the municipalities and the townships of the greater Barrington area. One of our purposes is to find strength and efficiencies in the governments collaborating with each other. And one of the big pieces of BACOG that goes back to its inception in 1970 is we have a regional comprehensive plan. And the plan deals with two major tenets. The first is managing development, and the second is protecting natural resources. So when we study groundwater, this is a critical natural resource, and it falls under, our work falls under implementing the comprehensive plan. Here are some statistics about BACOG. We're 90 square miles, about 38,000 residents, and we have 8 governmental members. So BACOG's governments work cooperatively to address regional challenges, and groundwater supply is one of those challenges. That's because we're all dependent on groundwater here in this area, whether you have a well in your backyard on your own property, or whether your municipality or your subdivision provides water to you. It's all coming from the same source. It's the same water. So where does water come from? Well, that really depends on where you live. And now we're going to take kind of a big picture view of water supply. So in this big region of northeastern Illinois, there are 3 sources: Lake Michigan water, the Fox River, and groundwater. So you'll see in this map that Lake Michigan water is in light blue, and the inland surface water, that means river water primarily, that's the light green, and groundwater communities supplying groundwater to the residents or themselves is in dark green. You'll see in our area, which is right in here, we're all on groundwater. And in case you didn't know, really and truly, this is not a myth, we do not get Lake Michigan water in the greater Barrington area. Now, this information is a little bit dated, but the percentages probably have not changed much since about 2000 when it was put together. It's pretty clear. Most of the residents in northeastern Illinois get Lake Michigan water, a vast majority. A very small amount use water from the rivers, and about 15% use groundwater. And the majority of those using groundwater are taking water from the shallow aquifer system. These are the aquifers in the first few hundred feet below ground surface. And in the BACOG area, nearly 100% of wells, let's call it 99.5% of the wells, are located in the shallow aquifer system. This is a great slide because it shows very simply what the aquifers look like below ground. This is a cross-section, so it's showing on your left, it's showing to the west of the BACOG area, and on the right over to the east side of the BACOG area. So there are several aquifer units and systems below ground. We're going to start at the bottom and work our way up. First of all, the gray areas, the gray colored areas, are called confining layers. That's mostly shale and clay and soil materials that are highly impermeable, so water doesn't travel through them very readily. So at the deepest, we're looking at the lavender formation. That is the Mount Simon aquifer, very deep, a little bit saline at the bottom. Above that is the Galesville unit, and that's in the kind of bright blue color. And then Deep, but a deep aquifer, but not as deep, is the unit above. It's called the Ansel unit. It's shown in green. A lot of municipal systems are in that unit. And above that, in yellow and orange, is the shallow aquifer system. And that's the system that our residents rely on here throughout the Barrington area. You might be surprised to see how small the depth of the shallow aquifer system is, or the breadth of it, in comparison to the thousands of feet of the other aquifer units. In the BACOG region, that orange section of shallow aquifer system can be anywhere from 250 to maybe 325 feet below ground surface, where the shallow bedrock, shown in yellow, exists. And so it's both the material above, which came from, there were soil materials laid down by the most recent glaciers that melted in our area, and then they sit on a rock formation that's called shallow bedrock. All of that is the shallow bedrock system, or the shallow aquifer system. And again, whether you get your water from a private well, or from a municipal supply, or a subdivision supply, almost 100% of that water is from the shallow aquifer system, and it's an interconnected system, so the water is pretty much the same water. It's not only the same system, it's the same water. A couple of points. A few wells in BACOG are in the deep formations, the deep aquifers. Mostly they're for industrial purposes or for large-scale irrigation. The deep aquifers are solid rock, even though they look like this looks like kind of like a river. It's not. It's solid rock, but you can extract water from it and pump it out. And there are no underground rivers in the greater Barrington area. They do not exist here. They exist in other parts of the state and the country, but not here. It's all solid material, or soil material, that's saturated with water, where you can drill a hole and pump water out. So why study the shallow aquifer system? Well, we're almost entirely dependent on groundwater. Nearly all of our wells are in the system, and growth continues. Within BACOG and outside of BACOG, there are going to be more residents here who will consume more water. There's no alternative supply, no Lake Michigan water, no river water, but regardless of the supply, there's no infrastructure to distribute an alternate supply, or very little of it. So we have, in about 90 square miles of BACOG, 80, 90 square miles, we have over 7,800 wells. Only a handful of those are public community municipal wells. The rest are single wells on a single private property. So if anything happened to the groundwater we're pumping into our homes every day from those wells, all of those wells, we would have a problem. And we need to know that the water that we're pumping out of the aquifers, it's vulnerable to contamination. We need to know what the water quality is and where the aquifers are vulnerable, and so on. We have thousands of acres of natural areas, many of which are fed by groundwater from below, so the water flows upwards into the natural areas. There's a lot at stake, so environmentally and economically, so we have every reason to study and protect our groundwater supply. When I started the groundwater initiative back in 2001, I had 4 basic questions. Where is the water? How much water is there? What is the water quality? And importantly, is our groundwater sustainable? So you might be thinking, is there really a risk? Is there really a risk to our groundwater here? Well, going back decades, there has been concern in northeastern Illinois as development proceeded westward and northwestward from the city of Chicago. There were planners at some of the major agencies in the metro area that were concerned that a day could come when the resources were not adequate to support the growing population. This is a figure from an organization that used to be called the Northeastern Illinois Planning Commission, NIPSI, their 2002 strategic plan for water resource management. And it stated that future water supply and use did not match, and that groundwater was not a sustainable water supply. In the figure to the left, this is the 2002 estimate of the year 2020 water surplus and shortages by township. And several of the townships in the BACOG area, adjacent to and in BACOG, right in here, are shown in dark purple. Those are the townships that are subject to shortages. Since then, a lot more building has occurred in the collar counties, and more areas probably have that designation of potential shortage. So we know we need to be concerned. More recently, 2009, this is a figure from a report done by the Illinois State Water Survey, and this is about the shallow aquifers in Kane County. And you'll see the boundaries of Kane County are in blue, but, I'm sorry, they're in black. But the BACOG area is right here. We're in their buffer area. They need to go beyond the study to generate correct information for the county. So up in this area, we're looking at, first of all, we're looking at pre-development, which is about 1864, through the year 2003. And in our area, we are looking at drawdowns on the groundwater levels anywhere from 5 to 30 feet in the villages of Barrington, Barrington Hills, Lake Barrington, and South Barrington. So this is a lot of water that we used to have pre-development that we don't have anymore. That study also made projections from that point of 2003 through 2050. So it's projected, in the report, it's projected that in our area there will be a drop in water levels over the next few decades of 10 to 20 feet drop in water levels, groundwater levels, in the shallow aquifer system. That's in addition to what has already declined. So think of the impacts on our wells. Also, that report, the State Water Survey report, projected a 58% reduction in groundwater discharge to Flint Creek and Spring Creek watersheds. Many natural areas, as I mentioned, like wetlands, fens, and streams, are dependent on groundwater pressure, forcing groundwater up into those areas. So if we have that kind of reduction to those areas, we have some changes ahead of us, possibly. So those are the scenarios we're looking at. Now we're going to look at groundwater quality for a minute. So a different study by the Illinois State Water Survey looked at a number of water quality components, all in the shallow aquifer system. So we're going to look at just one right now, and that is chloride. Above 250 milligrams per liter, which is the standard there in the legend, water tastes noticeably salty. The red dots on the left-hand side of the figure, the left-hand figure, those are at, or I think they're about at they're above 250 to 500 milliliters per milligrams per liter. So they already have problems in the eastern portion of Kane County with chloride. The Illinois State Water Survey study concluded that groundwater quality in the eastern urban quarter of Kane County is degraded, and you will see that since 2003 to 2015, the chloride has worsened. So there are more red dots, and they are larger red dots. Now, road salt runoff contributes to a major source of this chloride contamination, which means that people in those red dot communities could be drinking some road salt. Well, we don't want that. So in the BACOG area, keep in mind that salt also gets into the groundwater from roads, of course, but also from our water softening systems and from what you as residents put down on your driveways and sidewalks to keep them ice and snow free. So this figure is from the same report, and it addresses arsenic in the groundwater. And you'll see in Kane County there are 10 wells with arsenic above the drinking water standard, which is 10 micrograms per liter. 9 of these wells are located in the shallow bedrock aquifer. So arsenic can enter the water supply from natural deposits in the earth. As the groundwater flows through those soil materials, it picks up certain elements like arsenic, and it can also come from above. It can come from industrial or agricultural pollution. But there's some research out there that shows a line of thinking that arsenic dissolves out of these certain rock formations when the groundwater levels drop significantly. Another reason we should be concerned about the water levels. Now you can find those reports online, and they're very in-depth and long, and they're wonderful because we have terrific state water surveys. So why study BACOG's groundwater? Well, it goes to the impacts on our communities. Can you imagine a house without water? Well, that goes to water supply. People would have to drill their wells deeper. They might have to drill a new well. They might not be able to find a good water source. Think of the cost of that to residents. Or a house with salty water, or worse in terms of contamination. You can treat that water to remove certain things, but maybe it's not possible to remove certain things. I mean, we're looking far into the future here. But again, it goes to the cost to residents. It also goes to the environmental and ecosystem changes that would come from either a water quality or water quantity change that was significant. And ultimately, it goes to the decline in property values. The areas that define us, the natural areas, the homes having drinking water available to them, define property values as well. So going back to 2001, when we created the Water Resource Initiative, there have been new components added to the whole program, the whole project, and they address the basic questions of water supply, water quality, and sustainability. And this is what they are, and I'm going to talk about them individually. So mapping and modeling was our first component, the first thing we did. We characterized the water supply and the wells in the area by number of wells, types of wells, locations of wells, depths of wells, and so on. And then we outlined a study area. The footprint on the right is the dark green, is the BACOG area, originally when we first started doing this study. It's about 90 square miles, 80, 90 square miles, dark green. But the project needed a buffer. Like the Kane County buffer that the BACOG area is in, we needed a buffer for BACOG, and it's really pretty large. It's about 600 square miles, the size of a typical county in Illinois, and that's the entire light green area. So we obtained the state's database of all well drillers' logs in the study area. There were about 26,000 well logs for our study area. And we worked with Dr. Kurt Thompson, who is a hydrogeologist and who volunteered for our project from the very beginning to help design a protocol for our study. So with his methods and with our GIS staff at BACOG, we analyzed every very detailed well log and characterized all of the soil materials below ground into one of four descriptions. Aquifer, which is blue, the light blue, aquitard and aquiclude, which are brown and tan, and those are the materials that water does not flow very readily through. It does some, but not a lot. You can't get water out of a well in an aquiclude, for example. And then at the very bottom, the navy blue is the shallow bedrock, which goes back to the yellow and the orange of the figure I showed you early on. So with GIS, we created a map of these units, aquiclude, aquitard, aquifer, bedrock, every 5 feet, showing what's there. Are they aquifers? Are they not aquifers? And where are those areas located? And this was combined into a very large stack map, which is this part of the figure, which is also very exaggerated vertically. So if we go to the next slide, this is this is the same information with all, I think it's 500 layers of stack map, stacked up and compressed to scale. So this is more a picture of what the model that we created at BACOG really looks like. This is a cross-section, it's a clip out of the model, and it's following the Route 14 Metro line, which also carries freight, by the way, from on your right, south of the village of Barrington, to on your left, almost to Fox River Grove. And what you see here is where the water is below any point along this cross-section, how much water there is, how deep and how extensive the aquifer unit is, and how close to the ground surface the water is, which is an important question for a planner or an emergency response person in taking a first look at if there's a spill here, which is below the green is like air, If there's a spill here, a contaminant could possibly go right into the aquifers. If there's a spill over here, it's going to take a long time for the contaminant to move down to the aquifers. But the model can answer questions on an initial level of how much water is there and where is the water. A really important product of the groundwater study was the groundwater recharge area map, which is shown in the reds and the purples on your right. This map can answer questions about where groundwater recharge occurs most readily and where potential contamination might occur. So we analyzed hydraulic conductivity below ground. How readily and quickly does rain and snowmelt and stormwater percolate down to replenish the aquifers? If the area is mostly clay, it's going to be a long time, and it's going to be shown in a shade of purple or gray. If the area is mostly sand and gravel, it's going to be a good recharge area, and it's going to be shown in one of the variations of red, from very sensitive to moderately sensitive down to very poor recharge. So knowing where recharge or contamination occurs or is likely to occur helps our governments plan for and understand more fully what happens if we have a drought. How do we address an accident? What about sustainability and additional questions? BACOG also facilitates private well water testing. So again, if you have municipal water in Barrington, say, or in Tower Lakes, or in a large subdivision like Lake Barrington Shores, your community is legally required to test and guarantee the groundwater quality. But if you have your own private well, you're the only one responsible for the water quality and maintaining a clean, safe water supply for yourself and your family. So this program that we offer at BACOG is just for private well owners. We have a level 1 testing program that tests for contaminants, stuff that gets into your well once it comes out of the aquifer and into the well column. It is for bacteria and nitrates, that is what we're looking for, and we run events at BACOG to make it easy for people to test their well water. The Lake County Health Department Laboratory is our partner in this program, and they do the testing at their laboratory. We use the BACOG Water Resources Committee to help staff the event and volunteer at the event. But what we offer to residents, the benefit to residents of doing this is they get a reduced rate, they have a local location to purchase their water test kits, and we drive their water samples to the laboratory in Libertyville. So there's very little transportation on residents' part, and it's also an easy, convenient location for both sales of the kits and collection of the water samples. We also do educational programs during every event on water quality, well maintenance, septic systems, and so on. So you get something from it when you bring your water sample in. So why do we do this program? Well, it's the theme of our water program. Know what's in your water. Do you know if you have bacteria in your well? Do you know if you have anything else in your well water? So in addition to helping make sure that residents are drinking clean, safe water, we also help answer the question that we laid out in the beginning of what is your water quality. The next private well water testing event is going to be October 11th from 11 a.m. to 7 p.m. at the Garlands. And there are postcards that you'll see at some community events, and check with your village or township website or newsletter to find out more information. Or go to the BACOG website at bacog.org. Again, we're trying to make sure that people are drinking clean, safe water, but we also want to raise awareness about groundwater protection. So we do level 2 testing as well. Now this is to test not for contaminants, to test your natural water quality. Now there can be contaminants in there, but they're different from the bacteria that we typically find. So what we test for are elements like arsenic, barium, boron, chloride, fluoride, titanium, and it's 25 to 30 parameters that are tested. So you take a raw water sample, untreated by water softener or any other system, and then know what's in the water as it comes directly out of the aquifer. Again, this is operated in conjunction with a state laboratory, the Illinois State Water Survey Laboratory, and we make it low cost and easy to buy your test kits. We ship them back for you, and it does two things. It helps you know what's in your water. It helps you know if your water treatment system is removing contaminants. And if you're going to buy or sell a property, it's an assurance to the buyer or the seller that the water is good. And there's another benefit, and that is one of the things we're trying to do at BACOG is map the water quality across the region. This provides data anonymously into our model that helps make our overall data, our complete data set better, so that when we do issue, we haven't yet, but when we do issue a water quality map and report, it will be based on lots of data instead of just a few points of data. What do we do with this data that we're producing is often a question, like, what are you going to do with it? Well, we provide information to our local governments, our BACOG governments, that consist of maps about the model, about water quality information. So we've written chapters at BACOG for each member's municipal comprehensive plan or township comprehensive plan to incorporate into their plan customized information about groundwater here in the BACOG area. It also offers a menu of goals and objectives for groundwater protection, where each community can choose what fits best with their community. What do they want to work on in the next 5 to 10 years under their plan? And since land use is a part of a comprehensive plan, it's a big part of comprehensive planning, this information can also help guide our governments in development decisions. For example, and this is a picture of development in case you didn't know, what densities are appropriate if the development will rely on private wells? Also, where should more intense development be located? Or where should one be located if it has the potential to produce contamination in relation to a groundwater recharge area? Well, those are questions that we hope our information will help our communities with making those decisions. Another application of the groundwater information is for environmental planning. The message is prioritize protecting land or acquiring land with good recharge capacity, because that will help not only protect that open space, but it will help encourage and support the replenishment of the aquifers. We all would benefit. So BACOG, our organization, is a member of the Flint Creek and Spring Creek Watershed Partnership. And the groundwater recharge area map was used in assessing open parcels that are most suitable for protection based on groundwater recharge. And what we found, this was a few years ago for the Flint Creek plan, we found that 4,100 acres of important and critical, highly sensitive recharge areas were identified in this watershed, Flint Creek watershed. So again, the message is help protect those areas. We do public education, and we have brochures on our website, and we make them available at events. And this is one of them. This is the most recent one that explains the shallow aquifer system, how it works, and how you might, on your own property, impact someone else's well or your own. You don't want to do that. This is one of the tools we use at our water testing events. It's Arnie Rappa from Lake County Health Department. We purchased, BACOG and Lake County purchased this model together, and it's like an ant farm. It's a model of the shallow aquifer system in our area. And then you can introduce dyes and water and so on to show how water flows below ground and how contamination also might flow below ground. We have a recent youth education component that the Water Resource Committee and our staff developed over about 2 years. So it's an enhancement to the elementary curriculum in District 220. The curriculum is on land and water, and it's customized, again, right here to what's under your feet. Where's the water under your feet, and what's going on down there? So it addresses the major issues around groundwater, which is, where does water come from? This is for 5th graders, by the way. Where does water come from? How does groundwater get into the house? Is our area's water good to drink? Where does wastewater go? Septic, sewer, etc. how are the aquifers replenished, and is our groundwater supply sustainable? And it ends with what you can do. You as a student, you as a young person, you as a family, what can you do to help protect our groundwater? So it's in use in most of the 5th grade classrooms in District 220 this year, and I'm hopeful that it will be in all of them next year. It's also, this video is totally appropriate to adult audiences. In fact, a number of residents have mentioned how much they enjoyed it and learned from it. So you can see this video on our website at bacog.org. The program has a really fun piece that follows the students viewing the video. So the 5th grades are looking at it, and after they see the video, then they have a Skype session with the scientist. Now, our scientists are really scientists. These are hydrogeologists or groundwater hydrologists at the Illinois State Water Survey and the Illinois State Geological Survey, who coincidentally happen to be members of my Water Resources Committee. They are advisory members. But the students develop questions, and then they interact in real time with one of our scientists. This is Walt Kelly from the Illinois State Water Survey. So not only does this support STEM in the schools, but we're producing, we hope, young learners and advocates for groundwater protection. The newest program at BACOG is the Water Levels Monitoring Program. So this was approved in late 2013 as a new funded program. I think the why is clear, I hope. We anticipate declining water levels, but we don't know where that's going to happen or how much that's going to happen or how quickly it's going to happen. We don't even know if it's going to happen. So the only way you really know is by taking measurements. So the project started by creating a baseline to which all future measurements would be compared. And we just did the baseline in 2014, and so the next report will be 2019, and every 5 years thereafter. And what we will do is look at the water level information and compare it to the baseline to see what has happened, if anything. Have the water levels stayed the same? Are they going up? That'd be great. Are they going down? And if so, how quickly and where and so on. So our trends that we identify will be established using real data that become the basis for local action if we need to take local action to protect our water supply. So what are the data sources that we're using? It's a short list, but it's a lot of data points. But this is where we get all the measurements, and I'm going to show you in the next few slides kind of where they are and what they are. So first, a map of where most of our data points are located. So this is the BACOG area, all of our 8 member governments. And then this is our kind of our buffer area. But you'll see a lot of the red and yellow points are within BACOG, but there are a few outside of our municipal or our BACOG boundary. That's again because we need a buffer area. And also, well, wait, I'll hold that point for a minute. So this is what the first item on the list looks like. The 3 monitoring wells that have transducers, which are data recorders that hang in the well, and then they have satellite telemetry with an antenna that sends the data from the wells to a satellite and then to the United States Geological Survey, USGS office in DeKalb, where they process the data and then host it on their national website of well data. So the locations for these 3 wells are North Barrington, Lake Barrington, and the South Barrington Conservancy. So under BACOG's contract with USGS, they host this information, and this is the site. You can see it all there. It's open to the public, and you can manipulate the data however you want, by time frame, by one community. You can compare wells and so on. Here, I'm showing you just snapshots from there. This is the North Barrington well and the Lake Barrington well showing 3 years worth of water level readings. By the way, those readings are taken every 15 minutes and transmitted once an hour via satellite. This, however, is a different view. This is the South Barrington well, and it shows a 24-hour period in July of 2017. So it's from that's not quite right. It shows July 3rd to July 10th. It's a 1-week period, sorry, almost. And then we have 15 monitoring wells that have no equipment in them. So what we need to do there is take the cap off, put an electronic tape measure down, and very carefully record the water levels. So this is us going out to a well and taking the measurement and then a sample of those 15 monitoring wells that have been measured. We take these measurements and several others all at the same time, synoptic measurements they call them, same date as the first week in July, so we have comparable readings year to year. We have 4 stream gauges. Actually, we don't have them. The Flint Creek Watershed Partnership got funding to install 4 stream gauges a few years ago, but we are helping and supporting them in that because we use their data too. So we're getting water levels in Spring Creek at 4 points, plus we're getting water levels from Poplar Creek, and someday we hope to have some stream gauges in Spring Creek. We also get information from 52 public wells in 13 municipalities, and that's just a data collection event. They turn off their pumps in their municipal wells for half a day, a few hours, and then they take a reading of water levels in all those wells. Well, you'll notice here, there are only 5 municipal wells in BACOG, but all the rest of those are out here in the buffer area. Part of the importance of those water level readings is because the water generally in the shallow aquifer system flows from the west to the east. So what's happening in those water levels, especially because there's a lot of development and a lot of population out there, what's happening there is going to influence significantly what happens to the water levels directly in the BACOG area. So when we talk about baseline, when I mentioned that term before, essentially what we're talking about is putting all the data together and generating a map, a contour map of water levels. What are they? How high are they? Where are they higher? Where are they lower? And so on. So this first report was done by Dr. Kurt Thompson, who was the hydrogeologist who advised our project for forever. We're still in touch. And then it contains information about how the project was done, the protocol for analyzing the data to generate a map. The report on the right, and both of these are online on our website, by the way. Report on the right is my report last year. It's interim. It's a data collection report, but it tells, if you're interested, it tells you a lot more about where the data sources are located, how they're used, what the readings have been for the last few years. So it's kind of interest. And then we're just looking at a bigger version of that water levels map. So this was done with data through 2014. The report was issued in 2015, and we will do the next comprehensive report in 2019. And the question is out there, what will we see? Well, one thing we have to keep in mind is that trends really don't show up in 5 years. Trends are more likely to show up in 10 years, 15 years, 20 years. So this is a long-term continuous program that will track what's happening with our water levels. So if you remember these questions, back at the start of the initiative, these were the questions that we posed. And we've answered a great deal under each of those 4 points. So where is the water? This is what we've done. Based on what we've done, we know where the aquifers are. We've mapped them in an interactive 3-dimensional model. We defined the groundwater recharge areas, and we know which land areas we should protect more highly maybe than others, both to enhance the replenishment of the aquifers and also to prevent contamination. And we're helping our governments at BACOG and local organizations like environmental organizations to prioritize groundwater protection and recharge areas in land use and land conservation. How much water is there? Well, we really can see where it is, and we can analyze where it is based on the maps and the models that we generated in the first part of our project. And also, we're going to know more about how much water there is from the more recent water level monitoring program. What's the water quality? Well, we know quite a bit about water quality in our area through our testing programs and obtaining the state's database of their historical water quality samples. And we've produced more data about natural water chemistry, which will be used to map water quality eventually through BACOG. And these programs also, though, have such a broader purpose, which is to help residents know they're drinking clean, safe, private well water. And we continue to raise public awareness about your source of water, where it comes from, the aquifers, and the importance of protecting them now so that we have no problems or small problems in the future. And we do that by distributing materials and information about our groundwater, bringing in experts to speak on groundwater, and we hope to make young advocates for groundwater protection through our early learning program. And finally, we are monitoring water levels in the shallow aquifer system, a really important program, again, where 99% of our wells are located. And that program will give us real fact-based information about if and how this critical resource is changing, and therefore how we might need to respond. So I think through BACOG, we have answered the questions pretty substantially that we posed at the beginning of this initiative, but I'm also sure that people can have additional questions about their own water or about the regional water supply or quality. And I would encourage you to reach out to our office at the Barrington Area Council of Governments, either through our website or to give us a call, or email me directly if you want, if you have specific questions, and I'll be happy to try to find answers for you. So thank you again for listening, and thank you for the community presentation opportunity through the Barrington Area Library.